So they have the formula for us. A of t, this is our final amount, equals A, which is the initial amount, which you'll see in a second here. And then you've got 1 plus or minus that growth or decay factor. So it'll be plus if it's growth, it'll be minus if it's decay. And then the t is the exponent, that's the number of time periods, which typically it's a year, right? Unless we're talking about like compound interest. So Tony purchased a rare 1959 Gibson Les Paul guitar in 2000 for $12,000. Experts estimate that its value will increase by 14% per year. Use a graph to find when the value of the guitar will be $60,000. So here's the graph, but how would we get the formula for this graph? That's what we have to figure out. So we can say f of x or y, or whatever you want to put there, equals the initial amount. The initial value for this guitar was $12,000. That doesn't get the exponent. The thing with the exponent is the growth or decay. So remember, it's 1 plus or minus. So it's increasing 14%. So we'll say 1 plus 0.14. And then our exponent could be t for time, or it could be x when we're graphing, because Desmos will recognize it with the x. So if we clean that up, it would just be 1.14. So 12,000 times 1.14 to the x power. So there would be the formula, and here's the graph for it. Let's see, I'll make that a little, I'll make it a little smaller. So it's starting at $2,000 here. Oh, 12,000, my bad. I was so confused by my own graph. We want to know when it's going to be 60,000. So if you trace over 60,000, it's 60,000 right here. Which then if we trace that down, it'll be between 12 and 13. So 12 years after 2000 would be 2012. So we'll say sometime in 2012. Sweet. All right. Oh, in 1981, the Australian humpback whale population was 350, and it's increasing at a rate of about 14%. We can form the equation off of that. F of x equals the initial amount was 350, and it is growth, so we are going to add it. So it was a 14% growth, 0.14. We add that to the 1, or the 100%, and it'll be like 114%. But in decimal form, it's 1.14 to the x power. When you chuck it in Desmos.com, the graph looks like this. Let's scooch it down a little more. We're looking for when it reaches 20,000 whales, which it's way down here at 350 right now. But 20,000 is up here. Let's see, it hits that. About year 31? Year 31. Let's see if they actually give us years. I don't remember what they said there. 1981. So 1981 plus 31. Let's see, 2, 1, 2012. Wow, that was a big year. That was the year the guitar value went up to $60,000, and it was also the year the Australian humpback whales went up to 20,000. So 2012. It's also that movie about the Mayan calendar. Ooh! Ooh!